Great, thanks. Well, great meeting all of you guys. Yeah, I mean, just by way of background, just so not because my background is particularly interesting, but just so you a little bit know of like who you're talking to and what we can dive into. I always look for points of commonality, and I heard a couple of you are working in education. I looked at I stalked you based on your email addresses, and it looks like a few of you are working in advertising and marketing, and there's some coaching and things like that going on. So anyway, I'll try and apply whatever we talk to help you guys with what I understand your purpose for this project is, which is called Reboot. Is that right, Nikki? Did I get that correct? Yeah. So how do we sort of rethink what we're doing, not just because COVID and everything else has majorly disrupted everything, but it's a good idea to do that every so often anyway. So my background, maybe that's a good way to describe what I've done, is I hit the reboot button a lot. When I was in college, I realized I really didn't like school, so I studied business to try and get out as fast as I could. I wanted to be a rocket scientist, but I was like, no, I need to get out of here. So I got out in 3 years and went to Accenture, which is a great big management consulting company. So I thought by going into consulting, I would, spend 2 years and then find out what I really wanted to do with my life. So I would work at I worked in banking, I worked in airlines, I worked in manufacturing on client projects. And what I realized is I didn't want to do any of those things. I wanted to do all of those things. I realized I could turn my weakness into, if not a strength, at least a way to keep myself occupied and entertained as I kept shifting what I was working on. And that led to, I went to a startup. So this is around 97, one of the .com boom startups. So that was a great ride. I was in Sweden at the time, and that brought me to the United States to set up the office there, to San Francisco specifically. And again, this was late 97. And the startup bug had really bit me. And so I started another company that together with some of the founders of the company I was with, that company, I didn't participate in all of these exchanges after I left, but Kroger, which is a big grocery store in the United States, sold the successor to that company last summer for about $500 million. I got nothing, just so you know. I'm not, I was a sort of inventor and early person, but I'm apparently not smart enough to stick with something that was pretty good. I went to another company called Forrester Research, where we basically did research about technology and how that was impacting businesses. And I specifically focused on manufacturing, automotive, aerospace, international trade, and things like that. So I wasn't doing health apps or things like that, but I did kind of feel at the time that the IT changes were getting pretty predictable, and in particular in the industries that I was working in. And so, as I mentioned earlier, I kind of always wanted to be a rocket scientist. So I went back to school. I started studying. This is on reboot number 7, I guess, at this point. I was again planning to have an aerospace engineering degree, and I had a biochemistry elective that was absolutely mind-blowing. So I pivoted again, and I went into biotech. I worked at UCSF, which is a medical school in San Francisco, in neurology and in bioengineering. I thought that was amazing. I could spend the rest of my life being fascinated by that, but I couldn't afford to, because I had kids in a house in San Francisco and things like that at that point. Wanted to pay for their college, so I became a biotech analyst, and that was my next job. So I worked in a company called Lux Research. We were a spin out from a venture firm called Lux Capital, and we were basically covering this transition from science into the market. It could be, again, biotech or industrial biotech or food biotech, but we also did things like energy storage, advanced materials like nanotechnologies. Just so my sort of curiosity kept getting fed. I really enjoyed that a lot. And we grew that company. So this is my third startup. We grew that company over, it took about 13 years to about 150 people, and then sold that company in 2017. So now we're kind of getting into where I am right now. So 2017, I knew I wanted to do one more startup at least, and getting older, knew I didn't have that many more opportunities to do that. I really enjoyed the maker movement, something I'd spent a lot of time with my kids, you know, making things in wood and in metal and with electronics. But I also saw this potential for it to be a manufacturing thing. And so that's where Nikki and I met. Is I was spending a lot of time at this place called Tech Shop that was basically a maker space and had all these tools for local digital fabrication. And like I said, I saw a lot of potential for that in manufacturing industries. So I was doing some consulting on, you know, kind of how do you take ideas into reality, and this whole process where we sometimes call like moonshot building or you know, long-term strategic thinking, Horizon 3. And one of my projects was with Telefonica. So Telefonica had a group called Alpha that was like the sort of Google X, where they would, you know, do their 2030 type of things that even R&D was, you know, it was too immature for R&D. So big ideas that would take that long to realize. And was traveling back and forth here a lot on that project. And then about a year ago, COVID hit, and also that project was winding down. And so two things happened. One, we took our project out of Telefonica and started up as our own company, and in a place called Makers of Barcelona. So the co-working space that we were set up in has, you know, laser cutters and 3D printers and all those types of tools that we typically think of as maker tools. But we're also very focused on AI and data and analytics and some of that type of thing. And so, yeah, that's been going for, we started working that about a year ago. Like I said, I was stuck here. I usually would have been in San Francisco about half the time. I was stuck here, but fortunately, in a lot of ways, because we got this company off the ground, on terms of, you know, life partner and things like that, this relationship that was, you know, long distance and very spread out became a lot more solid. And so, yeah, so I don't know how many times I've hit the reboot button, but it's like the space bar on my life, I guess. Just hit it whenever I need it. So hopefully that gives you a little intro to who I am and what I do. And yeah, I'd be really interested to hear about what you guys want to get out of this program, and if I can give you any thoughts or inputs or anything else. Nikki, how's that for an intro?
And thank you. I'm not sure how much the people in the room are familiar with the maker community. Maybe a quick hands-on survey by show of hands. Right hand up. Who of you is familiar with the maker community?
Okay, 2.5 is all I can see. Yeah.
So 3 are not familiar. I think it's good to give a quick intro into that space and what's happening there, and the potential, and also how to kind of keep a community of makers together. I think from that journey would be nice to share some insights, and that will probably lead into a conversation.
Okay, yeah, great. So the maker community is, well, if you, just from the name, you know, people who make things, it sounds very broad and very general, but you can really kind of maybe think of it as, what hackers are for code, makers are for other types of handicrafts. So it could be, when I say, you know, woodworking or, you know, textiles and sewing or things like that, you kind of probably think of the very traditional versions of those things. But this is a really more modern and updated version where, again, thanks to these tools that we have, that we can work with materials programmatically. We can, in other words, we can use a 3D printer or a laser cutter or something else where you're writing code, and then that's being, you have a modern, sometimes very expensive machine that turns your idea, your blueprint into reality in a much faster way. So you could say it's got some of its roots in like the, you know, craftsman and you know, very traditional handicrafts, but with a digital component to it. And I think around 2005 or so, there was this movement really took off. And that was due to a class that was held at MIT called How to Make Anything. And it was basically that, like, if you had, I want to make a bicycle, I'd like to make a pump for, water for, developing economies. I would like to make a dress that turns red when somebody I know approaches me. All these types of, like, almost, science fiction-y types of ideas could now be made in a with all these tools that we now had for digital manufacturing. And that class kind of took off, and there's they basically came up with a sort of almost like a standard. It was a kitchen. It'd be like a standard kitchen, like, here's the tools and materials you need to be able to make almost anything, and if you follow these rules, you can call yourself what they call a fab lab, a fabrication laboratory, a fab lab, and just set it up. And we'll share ideas, we'll share skills, we'll share tools and knowledge, and start to make these things. So there are, like, you might be familiar with a place like this in your city. You might have heard of one where there's these workshops where you can go and become a member, kind of like the way you'd become a member of a gym. You get access to equipment and training and a facility and a community that exists because they're into fitness. Well, this is the same thing, but for making things. And so you have these, again, this equipment, like a laser cutter is probably $8,000 to start. A 3D printer, like a really cheap, not very good one, would be a few $100s. The higher end ones are like, thousands. And so by sharing these pieces of equipment and how to use them and stuff like that, these skills with other people, you can really make amazing things. So people have made, again, prosthetic arms for amputees. They've made, some of the projects I made a tent for 7 people. I didn't know how to sew. And six weeks later, I was making a tent that, me and all my friends could go to Burning Man and stay in. So this repeatedly, like, learning a new skill that you had really no idea of how it even worked. And all of a sudden you're making something that, maybe it's not ready to sell at Target in volumes of millions, right? But it's perfect for what you need or what you feel like doing, and you had fun along the way. That's kind of the ethos of the maker movement. So today there are, I want to say, on the order of 3,000 or 4,000 fab labs around the world. Some economists have tried to calculate the economic output of this group, because a lot of times those ideas turn into products and services, or they get acquired. But these are people who work in big companies, and this is like a form of pre-R&D, basically, where they can again kind of try out some of their ideas without a lot of risk and cost. And then when they do, make sense, then they get scaled up.
That was a great explanation.
Okay. Yeah. Those of you who raised your hands, anything you would add? Anything I missed?
I think that's a really good explanation. I'm curious how you see where to see the maker movement going, because in a world where everything is moved to digital, two things are happening. One is we should not stop doing stuff with our hands.
Right. Yeah.
I think it's very important to not stop learning not forgetting the skill of actually creating something with your hands. And I can imagine it's tricky to meet on places where you share equipment. So I don't know, what happened in that community the last 18 months?
Yeah. Well, so there's I think I would say the fundamental reasons for having it are still, as strong as ever. Like you said, Nikki, the ability to make with your hands, to think with your hands, to build things. It's incredibly fulfilling on a personal level, but it's also really important economically. You get cities and even countries where they don't know how to make anything anymore, and they're totally dependent on other people for fulfilling their needs. And what happens is their needs actually end up being mapped onto what's available, as opposed to vice versa. So bringing back manufacturing to more developed economies, just having, again, the personal fulfillment of making something as opposed to doing a desk job all day. And I think from an economic point of view, distributing what we have right now is a highly centralized manufacturing infrastructure. If you're going to make something, like, it's all about, well, can you make 10 million of them, and can you get every single extra penny out of that thing? that's not necessarily the best thing for a robust and resilient economy. So on like from the societal level to the personal level and everything in between, there are a lot of reasons that this is still important. So with that said, I'd say the movement is in puberty. It's there have always been kind of tensions between like, okay, so the MIT guys I talked about, they started this and sort of put it out into the world as a not-for-profit, open source, open-ended kind of infrastructure, right? And then when it started taking off, some people came on and started launching commercial maker spaces because, for one, getting all the money to buy really good equipment, you need to have, hundreds of thousands of dollars to really equip out a good big maker space. So that kind of had its own takeoff thing. So there's a company called Tech Shop, and that's where Nikki and I met. And the tension, even like 10 or 15 years ago, between those two groups was palpable, because the open source people, they're academics, they're getting paid anyway. They had a lot of prestige in this. And then you had other people trying to commercialize it. And that was like, oh, you're sullying our, ivory tower, beautiful, gorgeous idea. And you're also making money. Why aren't we doing that? Right. So there was that tension. Right. And then within the companies that were making money, you started having all these expectations. So there was so much hype around this. I mean, President Obama, I love saying that word, don't you? Like President Obama, not that guy, not that other guy that just left. Anyway, President Obama had commissions on like local manufacturing, on citizen science, and all the things that the maker movement was about. And so there was a lot of money going into this, and some of the people on the commercial side really misspent that money. They really bought into their own hype. So classic kind of .com startup hubris, right? So I would say that those two main forces have, in a lot of ways, kind of torn each other apart, and it's really left up to the individual people who run those maker spaces and who have those connections, around the world to rebuild the culture in the community. The infrastructure is still there, but a lot of the culture in the community, I think right now, like I said, it's a little bit like puberty, where there's definitely an adulthood for this, but we're in the 14-year-old, I hate you, mom. My life is a mess, that stage. If you have teenagers, you know exactly what I'm talking about. So I'd say that's where it is right now. I certainly have hopes, and more than hopes, I have expectations that it will come out of it, and it will be its own thing. Every industry goes through this, and this just happens to be where it is right now. I should say also, so I mentioned my partner. So she and I met at a maker fair, the first maker fair in Moscow in 2016. And so we were both talking about this topic. And so here I am today. I guess I'm fully bought in.
So Thomas is the first one who raised his hand.
Yes, because my plan B before becoming a teacher was always to have a 3D printer shop. So back in 2012, I already organized and worked with the local maker spaces in Vienna, and was having my business plan ready. Then I said, oh, we have a job for you. Don't you want to start working on Monday? And yeah, 8 years later, a lot of things evolved. I spent a lot of money on Kickstarter and Indiegogo into robotics and diverse stuff regarding making IT more clear to young students. So there's, for example, the Pixel Kit, where you can interact with individual pixels and see how a flat screen is actually built up. Stuff like that. And one of the things I invested in was MakeBlock. Those were students from Caltech, California. And they had a very successful Kickstarter campaign with their Cody box. And now they are one of the biggest companies manufacturing mostly in China, with a lot of open source technology like Raspberry Pi, Arduinos. And to close the thing, I was the first in February of last year, the first certified educator by MakeBlock in Austria. And now we're getting a huge maker space at one of Vienna's schools and still organizing with that. Also now try to become self-employed. So I'm really amazed what's going on there. I think there's a lot of adulthood now there. And what I'm still missing is like those things I used to work with when I was in food processing industry. So, you know, to have real like chemical processes or manufacturing processes that you can build up on a small scale with your students, with the pupils, so you can actually watch what's going on inside a factory and dream up about their own factory they would build. And my childhood background was that I was always playing around with toy trains. They're very common here in Austria. We have 3 manufacturers. And of course, I had my own train set, and I always planned to build my own landscapes and trains and blah. And so I became interested because I wanted to control them. So I became interested in informatics and IT. So nowadays we have all this amazing technology, and I think it's really important that students still craft things by themselves, but also use modern technology to make it more easier for them to grasp ideas.
Yeah, that's great. I have to say, so Make Block was one of my kids' absolute favorite toys. The type of thing where they, fought like and it's a phenomenal set. I've recommended Make Block so many times because it works really well. The parts are incredibly well made. The systems, so I mean by that the quality of the parts, the way like Lego just always clicks. You can get your grandpa's Legos and they still work. Like those parts were really nicely made, but the systems were also just incredibly easy for going from like I know nothing about anything to computer vision and artificial intelligence and making little robots that find their way through a maze on their own. It's fantastic system. So thank you very much for backing those guys. I spent a lot of money. Hopefully you got some of it. Yeah, great system.
Niall, you're next.
Thanks. Yeah. So I live right in the centre of London. It's just very close to what we call Silicon Roundabout. So, full of accelerators, full of coders. And there are a couple of fab labs or tech shops, I guess, in the area too, but not many. I don't know whether they're connected. I don't see that when I see, I go to some of the accelerators, but are there more opportunities to connect fab labs and traditional accelerators? Is that something that is happening? Do you think it should happen more?
Yeah, that's a really great question. And it's one I've looked at a lot. And to be honest, I don't know that I have the answer to, because they tend to be very local. And by that, I mean, there's rarely, I mentioned tech shop and that's honestly, it's one of the messiest situations I've ever seen. I was a witness for the defense in as part of their bankruptcy and trademark trial and stuff. It was really, really bad. But all that due to egos. And this is what I wonder sometimes about these communities, at least at the scale where they seem to operate. So there's as much as they have these ideals of education and empowerment and stuff like that, there's also almost like an artist's community attitude of like there's a lot of cattiness and stuff, and I don't know why that is. It's really, I think, even shameful to see. And my intuition is that all of these things that come out of maker spaces are really the tools and the types of products that people are making are really the types of things that one person or maybe two can do. And you don't need to hand off your plans to somebody else for the most part. You're not doing 6-step assembly. You don't have this specialization. So the nature of the maker community is you learn all the skills. I was saying, like, I learned to sew, I learned to do CAD, I learned to 3D print, I learned to do metal shop. Like, so if I was going to hand that off to somebody to like save time or money, well, the whole point was for me to learn it. And so maybe I don't feel like doing that. So I'm not really sure that I'm not sure what the sort of upper limits of scale are for the maker community. The 0 to 1, it's perfect. 1 to 10, it's pretty good. 10 to 100, I'm not sure if that's the scale that really fits this community. At that point, you're starting to look at contract manufacturing or whatever. So I think that but there's still a gap between that and then what typical industry, would want to manufacture, where your minimum order quantity is, thousands, if not tens or hundreds of thousands. So I think there's a gap in there, and I don't see a real obvious bridge between the two. So
I just wonder sometimes, just having some more collaborative conversations between those two communities, or some niche areas of accelerators and the maker community, could really be interesting for that sort of intersect.
Yeah, I think like some of you have said on this call, is we've almost forgotten how to do these things, and there is an incredible amount of fulfillment to making something on your own. But then the next step is what you learn by doing that. So I'm not trying to sell my company here or anything like that, but that's basically what we did. Is we do really very deep analytical research using huge data sets, and the market and industry and technology research we do. We're using AI. We're using we're not just like making stuff up after a cup of coffee, right? But then when we go make it, we learn things that we never would have guessed. So like one of the projects we did last year was around. So this was pre the U.S. Capitol getting attacked, but when the Black Lives Matter protests were happening and things like that. So we basically designed this hoodie that was all the cyber physical security you would need on your personal protection, right? So it had, for example, it had a strip of infrared LEDs that were the same wavelength as security cameras. So when it was on, your face was essentially invisible to security cameras. It had Faraday cage pockets where you could put your phone in. It had a bunch of stuff like that. And so, we sewed these things, we made the electronics and everything else. But then we also gathered about 16 people. We did a focus group, and we talked with them about what do you think about this? What are some potential dangers? Do you think this would be a good product? Not because we intended necessarily to commercialize it, but for our clients, to get the feedback. One of them said, and this is the best takeaway, I would have never thought of this. He said, Pussy Riot in Russia really changed the aesthetics of protest, and the way now that people do these things, it's not a black hoodie, it's more like soft. It's like knitting a pink hat with cat's ears, or it's going for the complete vulnerability. Moms and dads out there with leaf blowers pushing away the tear gas, not throwing the tear gas back at the cop. So that type of stuff, like doing something with your hands. I don't know how many people are working in cyber physical security in the Silicon Roundabout type of area, but like that type of stuff is invaluable, and so it's a great place to have this confluence of disciplines.
Mark,
Thanks.
Wow, I'm fascinated by all of this, especially that hoodie. Like, I want one.
I'll send you a picture. Yeah.
Awesome. I have basically two questions, and they come from this focus of where I'm at. I want to develop a product, and I've spent some time around makers, but never really spent time in a maker's space or a fab lab. Mm-hmm. And I live in Northern California near SF in Marin. And so I'm curious about what the best local fab lab that's still in existence is for me to start to explore. Mm-hmm. That's like question one. And then the question two is, I actually want to create this thing that I want to scale up and manufacture and do a product development path with. Okay. But I want to kind of learn, like you were saying, and try different configurations of it, because there's pieces of it that might actually make it more valuable to the people that use it, but they might be too cumbersome to execute or not work very well. So I want to try different features and put it together and see how well whether it performs against my, metrics, without having to spend a whole lot of money hiring like a product manufacturing development team.
Yeah.
What do you do to protect your IP in an environment like that?
Well, first of all, the IP let's take that in a second. And so then I'm gonna ask you, what is it? No, but can you tell me a little bit about what type of product it is? Because there's different spaces that I think are better for it. Like there's
So
one
it's
called
a household, essentially bread box or appliance that you would keep inside your home, probably in the foyer, but maybe also in like the kitchen area or the living room. And I want it to have the capacity to have different external decorative elements so that you could have like one that's wood, one that's got like a more modern black finish, and maybe something that has more like a high-end kind of chrome polish look to it to try and fit some basic decor parameters. And what I was thinking about that was I could use super thin flat faces that have magnetization on them, and we could just make those and then pop them onto a surface. Or I could just decide, all right, I'll make one that's wood, that's generic enough that everyone will try it, and then if it takes off, I can start this secondary piece. One element it would have in it would possibly be like a Faraday cage style element, which would be like a copper box enclosure. But so that would be on the interior, i.e. between the face of it and the interior of it. And it's designed to create more connection in the home.
Okay. Yeah.
And
so
that's as vague as I'm gonna, like, I'm being vague on purpose.
Well,
I could just
so
go
it
ahead
sounds
and
like
say
all
it.
woodworking and metalworking, is that right? And
Yeah, it would. There's some electrical cords that would have to be brought into it. There's some, power that needs to come into it. And then I want it to look good because it's basically designed for the household of someone who has an aesthetic eye, and particularly maybe a woman who's, the householder.
Yeah.
I'm sorry if that sounds sexist.
No, it's I think we get the nuance. So yeah.
It's about,
it's not biology, it's not computer hardware. It's somewhere
really
between
simple.
like furniture, architectural, decorative. It's like that. Okay. So I would recommend the best space I can think of for you is probably one called Human Made, and it's in Potrero Hill in San Francisco. And they have, I think, what you're describing, you could actually, if it's what I'm picturing, you could make all those variations you're talking about pretty easily. You'd start with a wooden frame and a wooden casing, and you could do, there's lots of different treatments you could do for that. From three-dimensional solid wood to like laser cut, in other words, like finely, intricately cut shadow box and those types of patterns, or something in metal, or then you've got very close to that a material supply store called TAP Plastics, TAP Plastics, and they've got you walk in there and you're like in a candy store. Like there's so many things that you can.
Right. There's red. There's green. There's black, there's clear, there's
dozens, maybe hundreds of types of materials. So between those two, I would usually start with wood just because that's easiest to work with. And then we've got that, it's also less expensive. And then you've got that, you start going into metal, into plastic, and these other types of things. But yeah, you could get super creative with that. And I think Human Made they can teach you what you need to do. They can, help you where you don't want to learn something. You just want, another member to do something for you. So
right, the Faraday cage piece is challenging for me, and I don't think you could 3D print something that would have encased in it this Faraday cage. You'd have to make it out of copper or something, right? I mean,
there are conductive 3D print filaments that you could do, so you probably could actually make it. But I would say, that's your advanced project. Yeah, do that later. Do that second. You can just get there are textiles that will do that for you. So you could, if you create the shape
fabrics.
you want, just do that.
And here we have a maker crash course, Thomas.
Yeah.
And you have to unmute yourself.
Thanks, Nikki. You were talking before about the gap between 10 and 100. In Vienna, we introduced Industrial Meets Makers. It's organized by the board of the city of Vienna with the Digital City Vienna. And it brings together people from makerspaces with real needs by industry, for example, Siemens or whatever big industry is here in Vienna. And once a year, there is this find a partner summit where you can where makers come in and decide to work on which project with which company. And at the and I think so this is happening, I think, right now, so January normally, and by July or August things get finished, and in September, when there are the digital days, those accomplishments are showcased, and it's also an opportunity for makers to maybe get out of the comfort zone, see how a big company is actually working, getting new ideas, and even get paid for that in the end if it's a final product then.
Yeah, that sounds great. I think back to like you're saying, this bridge, this is really critical for the future of industry. We have so much focus on scale up and making things as cheap as possible, but we don't make many new things. And I think that's where this, creativity, giving creative people more access to tools and skills is really helpful.
Marco.
Yes. So I was thinking, can you hear me? Yeah, should work. So myself, I'm more like in the software area in terms of interests, and more following that part. Like the whole maker industry is very unknown to me, and I was just when I think about all the innovation happening in our world, you hear about, I don't know, Uber, about Airbnb, mostly software innovation. So I'm just curious, how do you see that in terms of density of innovators, in terms of density of innovations happening? The makers community compared to the more like software focused one, and also what do you think in terms of potential? Do you think there's at least my perception would be there should be so much more potential on the maker side compared to the software side? I don't know.
Yeah. Well, I mean, I would actually say, like, I wouldn't think of Airbnb or Uber as software innovations. They're business model innovations. They didn't create, like, if you think of machine learning, for example, all they did was build apps. Taxi companies could have built an app that did exactly the same thing as Uber, and there was VBRO, vacation rental by owner, long before there was Airbnb. So they just did a slightly better version of something that already existed from a purely business perspective. There is a lot going on in software, like, again, machine vision and speech synthesis and generative art and stuff like that. That's fascinating, but even that needs some type of a business model to get converted into something, again, like an Airbnb or Uber. I'm not super interested in that personally, just in that type of innovation, business model innovation per se. Again, because I think it's pretty easy to do, and it's just not intellectually that challenging. Software is harder, but hardware is really hard. And that's, I think, going back to all my reboots, like what I really liked about biochemistry and what I like about hardware, or making things, is that there's no Control Z, there's no save as and then go back to what you did. Like if you burn that thing, or you kill those cells, or your thing blows up, like it's not coming back. So you're focused, you're really in the zone on that. So if you wanted to get rich quick, I would say go do business model innovation. That's definitely the fastest way to do that. Software too is, again, you just have a lot more forgiveness. You have a lot faster iteration cycles, so you learn a lot faster. But what I'm interested is in how that, again, how automation and robotics are allowing us to do those things with hardware and even wetware with biology. So, I really never lost touch with the biotech side that I mentioned I was working in, and there's an amazing amount of stuff going on when you hear about like CRISPR and genetic engineering and things like that are really just starting to, I think, be now where software was in maybe the 80s or 90s. So if you're talking with your kids, I'd say focus on that. For you, if you wanted to try some stuff out, so there are a couple, like I mentioned, actually the make block system, or I did mention, but Mark mentioned Thomas mentioned the make block system. So in that, he mentioned this Arduino and Raspberry Pi. And those are two really, really, really inexpensive computer microcontroller systems. And when I say inexpensive, I mean the cheapest ones are like $5, and the most expensive ones are maybe 60 or 70. And what they do is they allow you to kind of bridge this gap between software and really simple types of devices, things that, you know, you would use in your house, or things that would, you know, like I said, make toys out of. But they scale up. You have people making supercomputer clusters out of Raspberry Pis. So they take like 300 of these $60 computers and they make a supercomputer out of it. And so accessibility to the hardware side, it's again, it's an entry level thing. Kids do it. But on the software side, it's kind of the sky's the limit. You can run, you know, machine learning and a lot of other really more advanced programming types of things on these devices, even though they're something that you can, you know, afford to buy a lot of.
Mm-hmm. Very cool.
I mean, for me, the fascination is not so much that we are able to sort of make things, it's the democratization, and we're moving. So we buy so much shit which is made in China and other places who are producing millions and millions and millions of stuff we don't really want, which we buy, realize it's not any good, and then throw it away. And I've worked with a few of the fab labs, and I have to tell you that almost nothing which people have made do they throw away. they then start recycling bits and pieces of it and make something else.
Mm-hmm.
And from a pure sustainability point of view, I think the more that we make things, or the more that we have an ownership of the stuff which is around us,
Mm-hmm.
the less likely we are to discard it when a new fashion comes out.
Yeah.
But, you know, maybe I'm just one of these guys who gets really fed up when people talk about, you know, get eco-friendly, discard your car, buy a new one. I'm going,
Mm-hmm. Yeah.
No.
Yeah. Well, that's funny. I'm laughing a little bit because, you know, there's one of these like maker manifesto posters, and, you know, rule number 17 is never throw anything away. I threw something away once and I needed it the very next day. So there's always, you know, something you can do with that old motor or that old, you know, device. But you know, more seriously, I think this you know, inability for us to understand our own devices, like how they work, how do we repair them, and things like that. Part of me wants to preserve that and say it's really it's character building, it's important, and it is almost an ethical, like, you know, thing in addition to the environmental thing. But part of me is also, you know, so many things are so obsolete, and repairing them is really futile. And so designing things not for necessarily for long life or for throwaway, but something in between where they meet their life cycle, but then they go back into a cycle. So you know, this idea of circular design, where when you make things for disassembly and for reuse, you know, when you design them as a design principle, the same way you design for manufacturability, you design for demanufacturability. So I haven't seen a lot, honestly, going into that. The economic incentives are hard because you have end of supply chain people and beginning of supply chain people, but maybe.
Yeah, but that happens when we outsource it to somebody else.
Mm-hmm.
We disassociate ourselves with the assembly or the manufacturing of whatever the bits and pieces which come together to this
Mm-hmm.
assembly.
Yeah.
When you have an intense knowledge of how things came together, then you can see what can be reused.
Mm-hmm.
And I certainly am not an advocate, I don't think anybody is, of repairing stuff which is past its sell-by date. On the other hand, you know, there is something about discarding stuff unnecessarily because IKEA or IKEA have persuaded us to buy something else.
Mm-hmm. Yeah, I was at a museum exhibition last weekend. So I'm in Barcelona. We can go to museums sometimes. But some friends of mine had actually made the exhibit. So it was about water, and it's about the water system here in Catalonia. And at the end of it was this this beautiful contraption with a huge tank of water that led into all these other tanks, and you could vote. It would ask a question, and everybody pressed a button, and some water would come in. So the height of the water told you how many people had voted for different things. Really beautiful structure. And I said, like, this whole exhibit you guys have done is gorgeous. And every city in the world has some need to educate their people about water, and you know, you could move this to another museum or make more of them. And it's like, yeah, but we just didn't design it for that. Like, in their budget, it was designed for like one time, and they can't even really effectively take it apart. So it will be scrapped, right? So yeah, there's a cost to designing things that way up front. And I think if we can think ahead of its immediate first use to its second use or an adjacent use, then we can start to incorporate that into our design practices.
I'm curious about what your, like, right now, today, firebrand thing that you're really into today. Like, what's the thing you want to make today that you woke up thinking about?
Well, okay, so there's what do I feel like doing if I had no obligations to anybody but myself? And then what's most important for like what I'm working on. For it was just, so the stuff just for me, I'm really fascinated by what are called brain-computer interfaces. And so basically ways to connect your nervous system with a machine and vice versa. And it's both a kind of a read-write conversation. And so like normally you would think of things like if somebody's lost their arm, you can give them an arm that they can control. Like that's a kind of a easy thing, or you could type by thinking. You just think of a word and it would show up on your computer screen. But I'm interested in the other direction, like having machines control bodies, and that would be implanting thoughts, controlling muscles, or causing sensations. And so we're actually doing some stuff on that field too, where I'll just like give you one example. So we're looking at how can we decouple the flavors and other sensations we associate with food with the actual food, from the food itself. So, there's calories, there's sugar, there's all these reasons like we just eat because something tastes good, but we don't really want to eat if we just have that. So we developed this thing. You've probably seen this map of your tongue where there's different flavors, sour and bitter and sweet and whatever on different parts. So we developed like it's kind of like a sleeve. It goes on your tongue, and at different areas it has different electrodes. And so we can just give a little bit of current in these different places and induce these flavors. And like I was saying earlier, there's so much you learn by actually building something and then just messing with it. And so we were doing that, really just not knowing what good it would be for it all. And one of the people on our team, her ex got COVID. And as you know, one of the symptoms is you lose your sense of taste and smell. And so we said, wow, well, can we put this in him? Will he be able to taste? Like, what's going on? And we found out, no, he couldn't taste anything with that either. And so, I don't know if we did any new scientific discovery there, but there's all these theories about like, does this affect because it affects your brain, or is it affecting some other part of your body? And this would imply that it's affecting your brain. Your tongue can still taste stuff, but that signal is not getting up to your head. And so, or all the way up to the top. Anyway, so that kind of stuff just fascinates me. And I don't see that, it's so primitive right now. I don't see that being solved anytime in my life. So that's what I would work on if it was just like up to me.
Now, can I ask a kind of risque follow-up to that?
Sure, go for it.
It seems like one of the leading edge places for that technology to get like funded is in the whole like South Asian sex toy, like bot girl type of things. Have you looked at that as one venue for this idea or not?
I have not, but a team member actually tomorrow is doing a sex toy hackathon. And so, yeah, and to be honest, I'm not prudish about it, or it's not that I would be doing it, but I have just too much other stuff to do. I also I don't know. I'm not super interested in that topic because that, there's a lot more human connection stuff to that I think that I don't get the robot thing personally. So
Yeah, me either.
yeah.